Good morning, folks. So yesterday you just did some integration and the thing that's probably been annoying you a bit is the fact we've got this plus c on the end. And you may remember, or I hope you remember, that we've done a lot of stuff with straight lines where you have y equals mx plus c and you found the gradient. So it might be y equals 2/3 x plus c. Then you know one point and you can substitute that point in, find out what c is, and you've got the gradient of the line. Now that is true for curves as well. Have a little look at this. Now, the first thing I reckon you're thinking as soon as you look at this is, I know Mr. Godber did art at A level, and indeed I did, and yeah, beautifully drawn, isn't it? Anyway, we've got three related curves here. They're all, you could call them y equals x squared plus c, because they're all y equals x squared, but where they go through the y-axis is different for all of them. Y equals x squared passes through when y equals 0. Y equals x squared plus 2 when y equals 2. And x squared minus 3 when y is minus 3. Apart from that though, they're the same curve. But if you were to draw these up forever, they would never quite touch. They never share the same points. And that's true of any equation that you can think of with all your different varieties of x squareds, x cubes, various things going on. It might be wiggling all over the place, but if you've got one point, that won't be the same in all the other related curves, because it's just, if you add c to it, that's just going to move the whole curve up a tiny little bit. Therefore, if you know one point at some point on this curve, you can substitute that point in and solve for c. You'll be gutted to hear I'm only going to talk you through one example today, but it's got a fair bit going on in it. So copy it down, have a look at it, and then yeah, see if you can work out what's going on. You're going to have to integrate, then you're going to be substituting a point in. Get as far as you can, pause it, and then see where you're going. Now, first of all, we know that what we want to integrate is that. So let's write that down, but we want to split the denominator here so that we've got x squared over the square root of x is x to the power a half, isn't it? And then you've got 2 over x to the power a half, and then we want to think about how we change that into single power of x. So 2 to the power 2 divided by to the power half, you take the powers, don't you? So that's going to leave you with 1½ left, which is 3 over 2. And here you just keep the same power, but it becomes negative. So that's what we have, and that's what we need to integrate. So if the differentiated part looks like that, the original function of x is going to be this integrated. So first of all, we want to add 1 to 3 over 2. Well, 2 halves are 1, so if we add 2 onto the 3, that gives us 5 over 2. And then we need to divide, but it's only 1 that we need to divide by, so I am going to take a bit of a shortcut. When I divide by 5 over 2, I'm going to end up multiplying by the reciprocal, so that's going to give me 2/5. And then here I'm going to be doing, I've got -2, I am going to write this out, divided by -1/2. No, I've messed that up, haven't I? Because my power of x, I've got to add 1 to the -1/2. It's going to give me +1/2. So I'm dividing by +1/2 there. And when I divide by 1/2, that is the same as multiplying by 2. So that's going to give me 4 as my coefficient there. I'm going to write that out to clear it up down here. So my function of x, I'm going to remember, of course, that the function of x, when you put it on a graph, is in the form of y, and we want our equation. So I'm just going to turn that to y now, and I've got 2/5 x to the power 5 over 2, and I've got there was a negative there, wasn't it? Negative 4x to the power half. And what have I not put up here? Plus c. And the whole point of today is we're finally going to find out what that plus c is in a specific situation. So that's my equation. It was going through the point 4, 5. So we're going to substitute the point 4, 5 in there. So that means x equals 4 and y equals 5, doesn't it? So I've got 5 there, and then I've got 2/5 times my x is 4 to the power 5 over 2, and then take from that 4 times 4 to the power of a half plus c. Now what I would do at this point is, you can work it all out, but you do have your calculator, so it's a good idea just to pop this in your calculator. So comme ci, comme ça, as they say in French, press equals on that, and that gives me 24 over 5. So 24 over 5, I can put that in, 5 equals 24 over 5 plus c. Then if we take that away from c, is going to be 5 take 24 over 5, isn't it? Which is, since that is actually 4 and 4/5, isn't it? That is just 1/5. So c is equal to 1/5, and we're able to say that our final equation is y equals 2/5 x to the power 5 over 2 minus 4x to the power half plus 1/5. And once you've got that written down, I'd like you to have a go at page 294, exercise 13c, all of question 1, which is actually 6 of them to do, and then some exam ones of 4 and 5, and then quite a nice little modelling question on question 8. Now, if you find that you're getting a lot of this wrong, you might want to practice and do a few more, but if you can nail those, then you'd have done a good day's work. Okay folks, see you all tomorrow.